So there are 4 different instances in which you need to factor, or there are, I guess, 4 steps in which you're going to take. And the first step that you always look for is whether they have a common factor. So you always look first. You always look first and see if there's a common factor, which just means something that they all have in common. Kind of self-explanatory. If you see an expression that has only 2 terms, then it's going to be one of 2 things. It's either going to be a difference of squares, and we're going to write all this down and then we're going to see examples of what that actually means. It's either a difference of squares, or if you see, so that's if it's an x squared. If you see an x cubed and it only has 2 terms, then it's going to be a sum or difference of cubes. And those are 2 formulas that you kind of just have to memorize when you see 2 terms. And we'll look at an example with those in a minute. Three terms is what you see the most often. That's supposed to be a star. 3 terms is what you see the most often. A trinomial is what it's called. And I'm just going to tell you right now that it's going to be trial and error. Like, we are going to guess and check. But I'm going to give you strategic ways in which you can guess and check and almost most of the time get it on the first try. So there are some steps that you're going to take. So we're no longer going to do the box. We're no longer going to do the little X thing because that takes too long. And I'm going to show you examples of how, or in which case, it wouldn't be appropriate to do a box method or guess and check, because most of these, or all of these factoring examples are going to be done without a calculator. So it's really difficult to do the box method or the X method if you don't have a calculator, because you get a value that's so large that you can't even find the factors of those in your head. Then if you have 4 terms, which sometimes you do, then you are going to factor by grouping. So I'm going to write out some examples. I didn't type all of these out, so we're just going to make our own notes. But examples of common factors. So here's the first example. If I have 3x squared minus 6x. So I'm looking for what the 2 terms have in common. So what can I take out? A 3x. So you're going to pull out an x with the highest degree in which they both have in common. So the highest degree is just to the first power. So once I pull out a 3x, what am I left with? X minus 2. Good. From there, that is all that I can do. There is no more factoring that I can do from that. So when you just have a common factor, that means that you can't factor it anymore. You can only pull out a common factor. From that, let's say that it were equal to 0 or something and you were solving it, then you would set each one of these equal to 0. So 3x equals 0, x minus 2 equals 0. So you get x equals 0, x equals 2. And we're not going to solve all these. I'm really just talking about factoring today because I know that you guys can set this stuff in parentheses equal to 0 and solve, but I just kind of wanted to reiterate what you would do if you were solving. Okay, next example. Negative 8x squared plus 16x. What should I take out? 8x. Should I take out a negative 8x? Or does it matter? It doesn't really matter. So if I wanted to take out 8x, then I would be left with what? Negative x plus 2. What if I wrote it like this? Would that be the same thing? Yes or no? Yes. So that would be the same thing. what if I wrote it like that? Would that be the same thing?
No, because the 2 would be,
It would be the same thing. So whenever I pulled out in negative 8x, I had to switch the sign of my 2 because think about it, if you're redistributing it out, you want to get back to the original. So if I multiply, I get negative 16 or negative 8x squared plus, because a negative times a negative, plus 16x. So any one of these three would work for that. Okay, next example. If I had x squared y a plus b minus x y squared a plus b. Okay, this one's like, this would be a pre-AP common factor. X, Y, A, B, X, Y, A plus B. So they both have an X and a Y in common, right? And they also have A plus B in common. So all of these things are multiplied by each other. It's like saying X, Y, Z, but the A plus B is just in parentheses. So can we all agree that they all have an X in common, they all have a Y, and they all have an A plus B? So when I take that out, then I multiply it. If I were to take X, Y, A plus B out of the first term, what is left? X. What is left in the second term? Negative Y. So X minus Y. Perfect. So those are examples of common factors. Those do get kind of difficult just because it's an easy concept. So something like this would be more prevalent on a quiz or test than maybe like one of the first two. Okay, number two. Number 2 is a difference of squares. It's the first one. So anytime you see something like square minus square, I'm drawing a picture. What I mean by square is like you can take the square root of it. So for part A, if I had an example, x squared minus 9. Here I have two terms. There is a negative sign in the middle, so it must be minus. Must be negative, or it must be a minus. Can't be x squared plus 9, or that will not work. And so if you think about it, when you look at these two terms, you can take the square root of the first one, you can take the square root of the second one. So when you factor this, it is something that you have to memorize, but it becomes so routine that you don't even think about it. This would factor into x plus 3, x minus 3. So essentially, you write out your two parentheses, you put your x's in the first, and then it's plus the square root of 9 minus the square root of 9. So when you take the square root of x squared, it's x. Take the square root of 9, it's 3. X plus 3x minus 3. So here's another example. What if I had 100 a squared minus 121 b squared? Would this still be a difference of two squares? Yes, it is. I would just need to take the square root of the first term, second term. So I'm going to set up my two parentheses. I'm going to put a plus and a minus. Now, what is the square root of the first term? 10a. Put 10a here. What's the square root of the second term? 11b. Yeah, so we don't even look at the sign in the difference of two squares. We just have to make sure if it's minus, then we can check that off. Okay, so this is a difference of two squares. Then I set up my parentheses. I put a plus and a minus, so put my signs first. Then I take the square root of the first term, square root of the second term. Okay, next example. What if I had 81 minus 169x squared? So what do you notice is different about this example as opposed to the other two? Right, so the first term does not have a variable. It's like the number is first and then the variable is second. But that doesn't matter. And in fact, it's almost better this way, that it's written this way, as opposed to negative 169x squared plus 81. Because if you had it written like this, you would look at it and think, oh, this is not even a difference of two squares. Like, I don't even know what to do with this. So when you switch the two and it becomes 81 minus 169x squared, then you can look at it and say it's a difference of two squares. And it doesn't matter if your variable is first or if it's last. And my suggestion is that if you have a negative x squared, move it to the last so that it's at the end. You don't ever want a negative x squared in the front, like negative x squared plus 81. You don't want that, because I've never seen anyone be able to factor that correctly. So if you switch the two and you write it last and you have the positive term first, then you treat it the same way that you would factor part B. And so let me show you what that would look like. So I put my two parentheses. I have a plus and I have a minus. So what is the square root of 81? 9. What is the square root of 169x squared? 13x. 13x. So it would be 9 plus 13x, 9 minus 13x. Yes?
So would a way to check it would just be factor it out?
Yeah, if you ever want to check your answer, that's what's good about this kind of test, is that you can actually FOIL it back out. Oops, that was an eraser. You can FOIL it back out. So you get 81 minus 13 plus 13 times 9. Those end up canceling, which that's why you have the plus and the minus, because the outer and the inner end up canceling. And then minus 169x squared. Okay, one last example. I'm just going to erase this. D. Okay, what about this one? X to the 10th minus 36. So I'm going to set up my parentheses. I'm going to put a plus and a minus. And the square root of 36 is easy. It just is what? 6. I'm going to put a 6 here, 6 here. What about x to the 10th? And this is kind of going back to my exponent rules. But when you multiply two x's together, what do you do with those exponents? You just add them. So what would go in the first term? X to the 5th. Y'all are so smart. So smart. So when I multiply x to the 5th, I end up getting x to the 10th. The only time you multiply exponents would be like if you had x to the 5th to the 5th. It's like a power to a power, then that would be the 25th. But if you're just multiplying them and they're side by side, then it becomes x to the 10th. Okay, the next one. So we talked about difference of squares. That's when you had an x squared. The next one is difference of cubed. That's when you have x cubed. So when you have a cube plus or minus a cube, call it the difference or sum of two cubes. And so the formula that you have to memorize this, unfortunately, but it becomes easier once you keep doing it. So if you have a cubed plus or minus b cubed, you see something like this. And all that means is you can take the cube root of it. So the cube root of 8 is 2. X cubed, if you see an x cubed function or something like that, then that's going to be your indication. Also when you only have two terms. The formula for that is you have a plus or minus b, and that's going to match, like, so if you have a plus here, you'll have a plus here. Then times a squared minus ab plus b squared. Sorry, y'all can't read that. A squared minus ab plus b squared. And that's if you have a plus, then it's minus and then plus. If you have a minus, I'm just going to do this in a different color. If you have a minus, so if it were a cubed minus b cubed, it would be a minus b, a squared plus ab plus b squared. And we'll do some examples. So let's say that I have, and I won't put too many of these on there just because we're going to, in second semester, we're going to go and we're going to have a whole unit on cubic functions. So we'll talk a lot more about this in the second semester. I would maybe have just like one of these on a test or something, not very many. And remember, you can always guess and check it. So if you get an answer and you think, I don't know if this is right or not, you can always go back and refoil it out. So we'll get this answer and then we'll go back and refoil it out just to show you. So I have 8x cubed minus 125y cubed. So here I have two cubes. My 8x cubed would be my a, my 125y cubed would be my b, and it is a minus sign. So I'm going to use the signs of the purple. And so what would I call my a? Like, what is the cube root of 8x cubed? 2, what? 2x. Good. I'm going to put a minus sign. What is the cube root of 125y cubed? 5? 5y. Good. Then I have plus and plus. This is where it gets a little tricky because if a is 2x, then a squared is what? 4x squared. Good. And if b is 5y, b squared is what? 25y squared. And so I'm going to put 25y squared here. Oh, it's not showing up. Okay, so we have our a squared and we have our b squared. And then my middle term is a times b. So ab, I would take 2x times 5y, and that would be what? 10xy. Good. So this one is just more of like finding a formula and plugging it in. So you get, if you have two cubes, you get the cube root of both of them. That becomes your a and your b. Then for these terms, you have to actually go back and square them. For the middle term, you have to multiply them together. Okay, when you have three terms, I did write trial and error, but there is a strategic. You might even want to put strategic next to it. It's not like you're just taking a shot in the dark. Strategic trial and error. It's kind of like a puzzle. I think you'll enjoy it. So, some guidelines. First thing that you do is you put your two parentheses because it's always going to end up like this. So, step 1, put parentheses. Step 2, decide the signs. So, you're going to put your signs first. How you decide is you look at the last sign. So it is based on the last sign. If your last sign is negative, so if it is a negative, then your signs will be different. So you're going to have different signs. Like one will be a plus and one will be a minus. And it doesn't matter if you do plus, minus, minus, plus. Like, it really truly does not matter when you start, because if you get it wrong, then you can just switch it in the end, and it's okay. If you have a plus sign on the end, then it's going to be the same signs. And how you tell whether they are both plus or they are both minus is by looking at first term, or looking at first sign. Step number 3, place the first term in each parentheses. Step number 4, place the last term in each parentheses. And then an easy way to check is you check the outer and the inner in FOIL. So I'll show you here in a minute. Some helpful hints, and really the only, like, these notes are helpful, but I promise you doing examples over and over and over is going to be the best. Helpful hints: if you start with the smallest numbers, like smallest in difference. So like, let's say that you had 42 and you needed two numbers that multiplied together to get 42. You would probably choose like 6 and 7 as opposed to 2 and 24, or 2 and 21, sorry. Can't multiply. Does that make sense? Like, you want to choose numbers that are closer together, because those tend to work out more often than like 1 and 42 or 2 and 24. And you also, this is one of the biggest things that's been the most helpful, is that you never have a common factor in a parentheses. So for instance, you would never have 2x plus 6 in a parenthesis, because you could pull out a 2. So you'll never have in one parenthesis two terms that have a common factor. So that's going to get rid of a lot of options whenever we start working them out. Okay, so here's an example. And the reason why I tell you not to do the box method and not to do the x method is because, let's say that I have 12x squared minus 13x plus 3. Now, if I were to do the box method, then I would need to multiply 12 times 3 together, find two numbers that multiply to get 36, add to get 13, and it's just kind of a big hassle, or it's harder. And I'll show you examples where it's even more difficult than doing like 36. So let's try this using the trial and error method. First step is I'm going to put my two parentheses. Next step is I'm going to look at the signs. So I look at my last sign. My last sign is plus. So that means that they're both going to be the same sign. How do I tell whether they're both pluses or they're both minuses? I look at the first sign. First sign is negative, so that means I put minus, minus. Now I need two numbers that multiply to get 12. Two numbers that multiply to get 12. And I'm gonna start with the two numbers that are closest together, like the two factors that are closest together. So what would that be? 4 and 3. So doesn't matter which one you do. What if I did 3x and 4x? So then for my last term, or my last two numbers, I need two numbers that multiply to get 3. Well, I only have one option. 3 and 1. Now, if I put a 3 here, that will not work, because why? Because they have a common factor. So I automatically, like if I put a 3 there, that will not work because of this common factor. So then that makes life really easy. I put a 1 here and I put a 3 here. Now I can go back and check it if I want. Checking it by, I know that the first and the last terms work out, but checking the outer and inner. So 9x minus 4x. Or sorry, negative 9x minus 4x gives me negative 13x This will work. Which means I'm good. So that's what I mean by this step right here, checking the outer and inner. I'm checking that my middle term works out. So I'm taking this negative 9x, and I would encourage you to write it out the first couple of times, maybe instead of doing it in your head. Negative 9x and negative 4x. Those combine to be negative 13, so we're good. Okay, with this one, so I put my parentheses first. Now I need to do the sign. So I look at the last sign, it's a plus. That means I need to go to the middle sign. The middle sign is a negative, so that means that these are both negative. Now I need two factors of 10. I'm going to go with the ones that are closest together first. So what are those two? 5 and 2. So I can put 5x here, 2x. Doesn't matter if you did 2x and then 5x. Either one would work, especially since the signs are the same. Now I need two factors of 4. So I'm just going to guess and check. So what are two factors of 4? 2 and 2. So let's just try 2 and 2, see if that works. Why will that not work? Because of the 2 right here. Can't do it. Sorry.
3 and 1.
Not 4 and 1. 4 and 1.
Oh, 4 and 1.
Okay, where does the 4 need to go? With the 5. Why can it not go with the 2? Because of the common factor. The common factor rule saves your life so that you don't have to make mistakes and erase. I would encourage you guys, though, I'm going to just be honest, you should use a pencil for these, just because we're not all perfect and we do make mistakes. Yes. Do what? Yes. I don't have an example. I can do an example with just x squared. It's the same kind of rule, though. With an x squared, you just put x and x, and it's a lot easier. I'm trying to do examples where this is not 1, because then whenever it does become 1, it's like so easy. It's a lot easier. Okay, let's do another example. This one is proof as to why the box method is awful and really hard. So, okay, for those of you that love the X method and I haven't sold you yet, I want you to, someone get your calculator out and tell me what, because essentially when you do the box method or the X method, you take the first times the last, so 24 times 18. So somebody tell me what 24 times 18 is. Somebody do it in their head.
No.
Because this is going to be a non-calculator question.
52. No, it's not.
Yeah.
Oh my god. Wait, hold up.
Can anyone do it without a calculator in their head?
520.
I have no idea. Okay, somebody get their calculator out and tell me what it is.
It's 520.
Is it 632?
I don't know.
It's 520. I'm done.
Samantha, will you do it for me on your calculator?
I'm moving up to 18. What am I doing?
You're doing 24 times 18, because this is what you do on the box method. You would, what?
I'm guessing it's 432.
I think it's
432.
432.
Yes, Roman. Okay, now will you tell me the factors of 432?
I just did it in my head.
Will you tell me the factors? Like, so what are two numbers that multiply to get 42? 432.
216.
Any more? What are the two closest ones? Without your calculator.
72 and 6. 36 and 12.
Without your calculator. See, that's the thing. You can't do it. You can't. You can't do it. But you can do this trial and error method without having to write out all the factors and things like that. No, this is fun. This is learning. Learning. So I'm going to put my parentheses. My parentheses. Okay, I have a negative sign, so that means that my signs are positive, negative. So you can do plus, minus. You can do minus, plus. You can really just do whatever you want. This is up to you. Okay, factors of 24. What are the two closest ones? Let's try those first. 6 and 4. So 6x, 4x. Factors of 18.
6 and 3. 18 and 1.
18 and 1? No.
You're dumb. 6 and 3.
Oh, you can't do
You definitely cannot do 6
I can't do... Okay, let's talk about this. I can't do 18 and 1 because why?
Because.
Common factors. I can take 2 out of both of those. 2 and 9.
Yeah, you can put the two.
Nope, the
oh, wait,
9
you
and
can't.
6.
9 and the 6. What else?
You gotta switch the
3 and
6
6. Can I do 3 and 6?
You gotta switch the 6 and 4.
I've got to. I can't do 6 and 4. Let's try 2 other ones.
8 and 3.
8 and 3. Let's try 8 and 3. Instead of doing, so Carson, you said 12 and 2. I'm going to work my way outward in terms of like how close they are together. So I try 6 and 4. Those did not work because of the common factor. Now I'm going to try 8 and 3. If that doesn't work, I can do 12 and 2. Okay, so I have 8 and 3. Now let's go back to the common, or to the factors of 18. We can do 9 and 2. Where would the 9 have to go?
8 first.
And the 2 would have to go here. Let's check it by doing outer inner. So outer, 8x minus 2x is negative 16x. Inner, 9 and 3 would be plus 27x. What do those add to be? 11x. Good. Now, let's say, for those of you, maybe, that didn't just copy mine and you did minus and plus. When you guess and check it, you get a negative 16, or you get a positive 16 and a negative 27, which means you get a negative 11x. So if your sign is wrong, all you have to do is just switch them. Think, oh man, I did that wrong, switch my sign, and it becomes plus and then minus. And we're good. So if you, in the end, when you check your outer and inner and you get the wrong sign, just switch them. Easy fix. Okay, let's try another one. Aren't these fun? It's like a puzzle. You're gonna get so good at this that I just can't wait to see you spread your wings and fly. Like, it's gonna be awesome. Okay, what do we notice about this one?
Can we flip it?
No, we can't. Because then you get this,
And that's a big no-no.
and it's really hard to factor anything with a negative in front. Just don't do it. You're gonna mess it up. I'm just trying to protect you. So don't. Leave it like this and be okay with it. Be okay with it. Don't let it bother you. Overcome your OCD-ness.
I can't. I'm claustrophobic too.
Factoring will not make you claustrophobic. Okay, so look at the signs for, signs are negative at the end, which means what? Different. Yes. Yes. Yes to all of the above. Okay, factors of 6, the 2 closest together. 3 and 2, good. Only one factor of 2, which is 2 and 1, but where does the 2 need to go? With a 3. Make sure you don't forget your x's. Now let's guess and check with our outer and inner. We get a negative 3x and we get a positive 4x, which gives me a positive x. Flip those signs. Flip them. Flip them. No. Yes. Yes. Then you are done. Then if you want to go back and check it, you can. If you are one of those people. Okay, so if we have 4 terms, we are going to factor by grouping. I love grouping.
And why do you use on?
Okay, so if you have, let's say, example, 3x cubed, 3x cubed, I'm going to rewrite that, minus 5x squared plus 3xy minus 5y. Did you know that this can be factored?
Oh.
Whoa.
Did you know?
Minus 5. And what do you notice about these?
They're the same.
Good. They have to be the same, otherwise it doesn't work. So they must be the same. Sometimes you have to manipulate this sign right here and switch it for it to be the same. but you must have, the parentheses must be the same. So let's write that out to the side. Parentheses must be the same. When they are the same, I combine them by writing it as x squared plus y, 3x minus 5. And then I'm done.
Oh, that's it. I remember this. Yes, we did this in 8th grade.
These are fun. I like these.
These are great.
I wouldn't say great, but
Okay, let's try one more example and then we'll be done. So 18a to the 5th minus 6a cubed minus 15a squared plus 5. Also, something I want to write before you try this one, make sure, like when you get this answer, make sure that you don't have a difference of squares in there. So check to make sure you don't have, I'll show you an example. So for instance, let's say, I'm not going to come up with a new example, but like let's say that my answer were x squared minus 9, 3x minus 5. Like let's say that that were my answer. Then I would, so I can actually factor this again, and it would be x plus 3, x minus 3, 3x minus 5. So what I mean by that is like once you do your factor by grouping, make sure that you can't factor again. Like you don't have a difference of squares or you don't have a difference of cubes. And those don't come up too often, but sometimes they do. So just make sure. I would count off the whole thing. So your answer would want to be this instead of the one prior. So just always be aware of your surroundings. It's okay.
having so many teaching moments.
I know. So many life lessons in factoring. So much biblical integration. Okay, let's do factor by grouping on this last one. So what can I take out of the first two terms? 6a to the 3rd, and I am left with 3a squared minus 1. And I look at this second 2. What can I take out? And should I take out, so I want my first to be 3a squared. Should I take out a positive 5 or a negative 5? A negative 5. So then I'm left with, 3a squared. And then that would become what? Minus 1. Good. Now since these are the same, then I am good. And it would be 6a cubed minus 5. 3a squared minus 1. I cannot factor those anymore, so I am done.